So here it is, the official definition of derivative of a function, which allows us to find the instantaneous rate of change at a point on a function. It allows us to find the slope of what would be the straight line segment if we could zoom in enough. So we have our random point on a function. Here's our function f of x. And this point is at x sub 0, f of x sub 0. And if you looked at the video, you know that we're going to pick a second point, not on that point. It'll be h away. So its x value is x sub 0 plus h. And its y value is f of x sub 0 plus h. And to find the slope, we're going to do change in y over change in x, just like we were in middle school. So this guy's y value is f of x sub 0 plus h minus the other y value divided by this x value minus this x value. So x sub 0 plus h minus x sub 0. Now you'll notice something. You'll notice that these guys cross off. They totally go away. So what we end up with is f of x sub 0 plus a little bit minus f of x sub 0 all over h. And if we let this distance h shrink to 0, this point will basically move right on top of that point. So f prime of x sub 0 equals the limit as h approaches 0 of this, what we call the difference quotient, but what really is just the slope formula. So in the next few examples, you're going to see me applying this definition, and you learned all the skills you needed to do this back in Algebra 2. If you know how to plug stuff into a function and simplify stuff, that's really all we're doing. And then of course I taught you how to find limits. So we'll see how this goes. It's going to be pretty great. This is the definition of a derivative. It's called the limit of a difference quotient. It's something we definitely want to know and recognize and not let it freak us out, because it's just slope. It's the change in y over the change in x, and that change in x is always marked by h. So you want to know this, you want to recognize this, embrace this, enjoy it. Let's do some examples.